Problem 15 of chapter 4 reads that a ball is tossed from an upper story building at an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal. It hits the ground 3 seconds later. So we basically have gotten like a bunch of information from this one blurb alone. So now that we got the information from that one blurb, we're going to move on to how we're going to solve for A, B, and C. I'm going to tell you how to set this problem up because setting it up is the key. Here I've drawn my building. Here is my x-axis going down. Is my y-axis going down? Going down, and this is my axis going to the right. Right. I've labeled that down to my positive, so that means that gravity is going to be on my side, and that x going right is positive. So I drew my ball here, and I've indicated the angle of velocity, which is 20 below the horizontal. Now, since it's 20 below the horizontal, that means that the x and y components are going to be sort of like components of a triangle, like I've drawn here. This little thing here is going to be a nice big vector triangle. So we have our initial vector, which is think of it as the hypotenuse, or x component, which is going to be, which you see here is the adjacent angle, adjacent side, so that means cosine, and that means that y component is going to be by sine. So here I've set up as that velocity is cosine of 20 in the x direction, and velocity is sine 20 in the y direction. Now for number one asks us to solve for how far the horizontal base is from the building. So basically this length. So here I've set up my variables, and here I set up the problem. So you're just going to use the really simple problem of distance equals velocity times time. Plug in your x velocity and your time, which is 3 seconds, multiply them, and you get 22.55 meters. In the book on the back it says 22.6 meters, but they're rounding to a different number. I round to my hundreds. Okay, the y asks us how tall from what height was the building, from what height was the ball thrown. So we set it up as the equation that y distance is equal to the y velocity times time plus acceleration times time squared divided by 2. So I plugged in my variables. I plugged in and got 52.31 meters. Now the last question is, how long does it take a ball to reach 10 below the level of launching? 10 below the level of launching means 10 below the y-axis. So we use the same equation. So we use the same equation again. This time instead of a mystery distance, we plug in as 10. We plug in our y velocity. So we don't plug in time. We plug in our acceleration, and then we get a quadratic equation that looks like 4.9 times t 4.9 t squared plus 2.74 squared minus 10 t minus 10. I found that t is either equal to 1.18 seconds or negative 1.73 seconds. Since there is no such thing as negative time, I'm pretty sure that this is the right answer. So so that's how you solve problem 15. Thanks for watching.